Today our topic is drawing a ray diagram for lenses. So in this, first of all, we are considering convex lens. So as we know, there is a possibility of keeping object at six positions. For that six positions, we are getting the images. So let us consider here position 1. Okay, so position 1 is nothing but object is placed at infinity. So as we easily know that when the object is at infinity, the image is formed at its focus. So let us draw the ray diagram for that. So okay, so this is a convex a lens. So this is its principal axis. So here this is C2. So this is C1. So we are having the parallel rays. So when the object is kept at infinity, so we only get the parallel rays only. So when these parallel rays fall on the principal axis, so all are refracted to a common point. So here this common point is nothing but focus. So the image of the object which is at infinity distance, the object is at infinity distance, its image is formed at its focus. Next, if we place the object beyond the center of the curvature. So here the second one is the object is placed beyond the center of the curvature. So let us draw the ray diagram for that. So this is the ray diagram. So this represents C1 and this represents C2. Okay, so how we are going to draw the ray diagram? By considering the four in situation 1 to 4 diagrams, we will consider here any two, and by that we are going to find the image. Okay, so I consider the object beyond the center of the curvature. So this is object. So I considered from the top of the object a parallel ray, incident ray, which will fall on the convex lens and it will pass through its focus f1. Okay, so this is the refracted ray. Next I am considering from the top of the object which is passes through optic center, which is passes through optic center like this. Okay, so here this these refracted rays are met at this point. So at this point only we got the image. We got the image. So if we observe the image, so it is a real image and it is diminished in size. It is diminished and it appears inverted. So here we got a real image, it is diminished and it is inverted image, and we got the image in between focus and center of curvature only. Next go for third position. Third position is nothing but the object is placed on the center of the curvature. So here we are drawing the ray diagram for that. So here this is principal axis. So this represents C2. So this represents optic center P and this represents C1. So object is placed on the center of the curvature only. So this is object. Okay. So I am considering a parallel ray after incident. So it will refracted through focus point F. Okay, next I am considering another ray from the top of the object and which will passes through the optic center. So here, if we observe, so the image is formed exactly on the center of the curvature. So we place the object at C2 center. So the image is formed at C1 center. So if we observe the image, so the image is real, same size, the image and object size is same, and it is inverted. It is inverted. Why it is we are written here real? Real is nothing but the image is captured by the paper screen. We will see that image on the paper screen. Next, go for position 4. So here the object is placed in between center of the curvature and focus. So for that we will draw the ray diagram. So this is convex lens. So this is the principal axis. So here we are placing the object in between center of curvature and and focus. So here we keep the object. So this is object. So first consider the parallel ray. So after refraction it will passes through F1. Okay. So consider another ray. So from the top, which is passes through this optic center. So here we will get the meeting point, intersecting point here. So if we draw the diagram like this, so this is image. So observe the image carefully. So it is a real image, doesn't matter. But the size of the image is enlarged compared to the object. So the image height is more than the object height. So here that is enlarged image we got, and it is inverted. So it is also a inverted image. Next we go for position 5. So the object is kept or placed on the focal point. So here consider this is a convex mirror. So this is a principal axis. Okay, so we are identifying here. So this is the center of the curvature. This is focus, and this is focus, and this is the center of the curvature. So the object is placed on focus. So here we are placed the object on the focal point. So similarly here also consider, so the parallel ray, so which will after refraction it will passes through the focal point. Next, so consider the ray which is passing through the optic center. Optic center. See here, so these two rays are parallel, so they will not meet here. So it goes on like this only. If we extend back of the mirror also, so it will goes on like this only. So here this represents the image is formed at infinity. So here where the image forms at infinity. At infinity. Next we go for position 6. Object is placed in between the focal point and the optic center. So for that we are drawing the ray diagram. So see here, this is a principal axis. Okay. So this is the center of curvature. So this is C1, this is F1, this is C2, and this is F2. So here we are placed the object like this. Okay. So here if we place the object like this, so this is object position. Okay, consider the parallel ray like this, which refracted and passes through the focus point. Next, consider the ray, so which is passes through optic center like this, so it will not deviate. So if we extend back like this, so if we extend back like this, so all will meet at a common point. Okay, so at this common point, we got the image. So here that is nothing but when the object is placed in between center focal point and optic center, the image is formed here. So that is the virtual image, which will not captured on the screen. It is a virtual image and it is enlarged image and it is erected. It is a erected, enlarged and virtual image. So these are the possibilities of placing object in front of the lens. So for that corresponding, we found the image formations.